All right, guys. Hello, this is Mrs. Lyons. Today we are going to talk about dimensional analysis. Dimensional analysis is a tool that we will use to carry out calculations. And if you can get to a point where you're comfortable using dimensional analysis, is going to help you a ton during this semester. So dimensional analysis uses the relationship between different physical properties, physical quantities. By identifying their base units. Okay, another way we might see this termed is unit conversions. So for dimensional analysis to work, you have to use a conversion factor. And what a conversion factor is a statement. I will use the term equality statement, where two units are equal to each other. Okay, so for example, some common ones, things that we know. 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. Okay. Now, here's the thing about conversion factors. Our conversion factors are always going to be in the format of a fraction. So, for example, 1 minute equals 60 seconds. We could have two different ways of using that. We could say the fraction is 1 minute over 60 seconds. Or we could say that the fraction is 60 seconds over 1 minute. Okay, now here's the reason that we do this. Okay, if you think about math, okay, for example, if you're using fractions in math, okay, you can multiply anything by 1 and get the same thing, right? So let's just say I have 2/5. Okay, that's a fraction. And I'm going to multiply that fraction by 3 over 3. Okay, now the thing I want you to notice is 3 over 3 is equal to 1, right? So this is like I'm multiplying that fraction by 1. So I'm going to show you, if I do the math, 2 times 3 is 6, 5 times 3 is 15. Okay, now if you simplify this, what do you get? Again, you're going to divide by 3. So 6 over 15 can be simplified to 2 over 5, okay, which is the number that we started with. Okay, so the point of showing you this is to tell you that a conversion factor, the reason we use these conversion factors is because it's like multiplying the number by 1. And in doing this, we end up with a number. And in this case, in science, we won't simplify it back to itself because we'll be changing it to represent other units. Okay, so oops, I went too far in my slides. There we go. The key to dimensional analysis is to make sure that the units are, and this is when we set up a fraction. We want to make sure the units are diagonal from each other. Okay, and the reason for this is because if our units are diagonal to each other, they cancel out. Okay, so what I mean when I say that, it's kind of like, let's use our fraction example again. Let's say we are multiplying 2/5. Let's say we're multiplying this times 5/9. Okay, in multiplication with fractions, we know if you have a number on the top and a number on the bottom, those numbers cancel out. Okay, so our answer to this would just be 2/9. Okay, units can be used exactly the same. Okay, if we include our units as we're doing multiplication or division, the units cancel out if we have the same unit on the top and on the bottom. Okay, and this allows us to convert from one unit to another unit. Okay, so what we'll do is we will start with the value. When you're doing these problems, you're going to start with the value that you are given in the question. Okay, and then you're going to find a conversion factor that will, and I'll use the term equality statement. Okay, and by having this equality statement, this is going to help us get the units that we want to end up with in the problem. Okay, now in this unit and the next unit and the next and the next and the next, units are extremely important. Okay, so you always need to include your units for every step of every problem that you do. Again, and I said this a lot last semester, I'll say it a ton this semester, I can't give you partial credit if I'm not sure what you're doing. If you write your question so that I can read it, you include your units, I'll be able to tell if you make a mistake where you made your mistake, and I can give you partial credit around that mistake. If you don't write anything down, it makes it hard for me to do. All right, so as I said that, what that means is you're going to lose points if you do not include units as you go through the question. Okay. All right, so let's do a couple of examples. All right. So this question says, how many inches are in 45.3 feet? Something else I want you to do as we start going through this math is I want you to write down, I think you use this method in physics where you write down your given, you write down your unknown, you write your statement, your equality statement, or what you're looking for. So I want you to start doing that, okay? Especially at the beginning. Once you've mastered dimensional analysis, if you don't write down the given and the unknown, I'll be okay with that. But right now, until I tell you, you need to write this down so that we can look at the problem and address it the right way. Okay, so in this problem, our given, okay, or our known, I call it our given quantity, is 45.3 feet. Our unknown, or what we're looking for, is inches. Okay, and then our equality statement or conversion factor, however you want to word it, we need to have inches and feet. So what do we know about inches and feet? I know that 1 foot is equal to 12 inches. Okay, so now I'm going to set up my problem. Okay, and what I'm going to do is I'm going to set it up as fractions. I'm going to start with my given. So I'm going to write down my given 45.3 feet. I'm always going to put my given over 1. Okay, just get used to that. It's 1, no units. That's always going to go on the bottom of our conversion factor. All right, the next thing I'm going to do is I'm going to put my conversion factor in here as a fraction. Okay, and this is what I said earlier about kind of like multiplying by 1. Okay, so I have 1 foot is equal to 12 inches. We have to figure out what goes on the top and what goes on the bottom. the way that we do that is we look at, let's see if I can find another color ink. We look at this unit, okay? So since feet is here, let me highlight this. Since we have feet here, okay, we want feet to come down on the bottom of our conversion factor. So feet is going to go here. So I know that 1 foot, so 1 foot, and then what we're looking for goes on top is equal to 12 inches. All right, now I have to do the math. The thing to remember, this is just like you're multiplying fractions in math, okay? You multiply across the top, you divide by the bottom. Okay, and of course, anytime we have a 1, we know that something multiplied or divided by 1 is equal to itself, so we don't have to plug that in. All right, so let me get out my calculator and let's plug this in. So 45.3 feet times, since this is on the top, we're going to take it times 12. That gives me an answer of 543.6. Now, the important thing in doing this conversion is that the units of feet cancel out on the top and the bottom, leaving me with units of inches. Okay, now notice here I need to include my units, so I'm left with inches. And I'm just going to put a box around my answer. I'd like you to get used to doing that just so that I can see, I'm sure I know what your final answer is, what you want me to grade. Okay, so that's one. Let's do a second. Okay, a second practice. So how many pounds are in 92,840 grams? Okay, so I'm going to do the same thing. I'm going to start with my given. My given is 92,840 grams. My unknown is pounds. Okay. And my equality statements are given up here. Now notice this. There are 2 equality statements. All right. And if you look at this, we're trying to get from grams to pounds. With the equality statements I've given, I'm going to go from grams to kilograms and then kilograms to pound. So this technique of dimensional analysis allows us to use multiple steps to get between units. Okay, so I'm going to start with my given. So 92,840 grams. Again, I'm always going to put my given over 1. Now, this one's a little tricky. I have to figure out what is the conversion I need. Well, the thing that I do is if I look at my units here, I know that I have to have grams on the bottom down here so that it'll cancel out. Okay, so if I look up here, my 2 equality statements, there's only one of them that has grams in it. So I'm going to use 1,000 grams is equal to 1 kilogram. Okay, that's the first. Now, if I stopped here, my grams would cancel out and it would leave me with kilograms. But I need to get to pounds. Okay, so I need a second conversion factor. Okay, and this conversion factor, since I have kilograms up here, okay, I need to have kilograms on the bottom down here. So kilograms here. All right, now if I look at my equality statement, I've already used this one. I'm not going to use it twice. So I'm going to use this equality statement. 2.2 kilograms is equal to 1 pound. So 2.2 goes on the bottom. 1 pound goes on the top. This way, my kilograms cancel out. leaves me with the unit that I'm looking for, pounds. All right, so let's do this calculation. Okay, so I've got, 92,840 divided by 1,000. And then I can just plug this in all in one go, divided by 2.2. All right, when I plug that into my calculator, I get 42.2 as my answer. My units is going to be pounds. All right, and that is how you do dimensional analysis. All right, I'm going to give you some more examples to practice on. So we'll do that, and I'll see you in class.